real number. Exercise 1.2. For next exercise, fundamental theorem of arithmetic. This statement already underlined. If the question is there, state fundamental theorem of arithmetic, then you have to write this underlined portion. Then what is the meaning of this? Any numbers we can express into the prime factors, and this expression of prime factors will be unique. Unique means just you see then, but their order will be same. For example, I have written here 210 is equal to 2 into 3 into 5 into 7. You can write as well. You can write 210 is equal to 3 into 5 into 7 into 2. So just you see the prime factors only 2, 3, 5 and 7 in both ways. But their order are not same. Okay, this is the factor. Prime factors will be same. Order may or may not same. Next, find HCF and LCM by prime factorization method. Already you know find HCF by Euclid's division lemma. The next question, find HCF and both HCF and LCM by prime factorization method. One example is given here. Find LCM and HCF of 6 and 20 by prime factorization method. First you write 6 is equal to 2 into 3. 20 is equal to 2 into 2 into 5. That is 2 square into 5. So HCF is equal to, you get product of smallest part of each common prime factors. That is in between which are common factor, common prime factor, their lowest power will be HCF. And what is LCM? For each prime factor, product of greatest power. That is the product of greatest power of each prime factor involved in the numbers will be LCM. Now you get HCF is 2 and LCM is 2 square into 3 into 5 is equal to 60. Multiply them, that is HCF into LCM. 2 into 60 is equal to 120. Just you see, this is equal to product of two given numbers, that is 6 into 20. So from here you get the another formula. Just next, so we get another formula. HCF into LCM of any two numbers is equal to product of two numbers. From this formula we get the another formula. LCM of two numbers is equal to product of two numbers divided by HCF of two numbers. Again you get HCF of two numbers is equal to product of two numbers divided by LCM of two numbers. This is true for any two integers. But if there are three numbers, then this property, that is the HCF into LCM, not equal to product of three given numbers. So for verifying this, homework I have given, find the HCF and LCM of 6, 72 and 120 using the prime factorization method, and verify that HCF into LCM not equal to product of three given numbers. Next, exercise 1.2. Question number 1, I have done some questions and rest of your homework. Same way, I have solved some questions and I will give some question for homework. You write everything from the beginning of this chapter. Write in your classwork copy and complete your homework. Okay? Then any doubt, then ask me definitely. Okay? Here Exercise 1.2, question number 2. Find LCM and HCF of following pairs of integers and verify that LCM into HCF is equal to product of the two numbers. Here question 1, 2, 3 is given. So number 2, find HCF and LCM of 510 and 92. So first, you find the prime factors of 510. Prime factors is given here. So 510 is equal to 2 into 5 into 3 into 17. 92 is equal to 2 into 2, that is 2 square into 23. Therefore, HCF is equal to the common factors, their lowest degree. So 2, LCM, highest degree of common factors into other factors. So 2 square into 5 into 3 into 17 into 23 is equal to this. Verification. First find HCF into LCM. Again you find product of two numbers. Both is same. So you can tell HCF into LCM is equal to product of two numbers. It is verified also. So next question number 4. HCF of two numbers 306 and 657 is equal to 9. It is given. Find their LCM. So we know the formula HCF into LCM is equal to product of two numbers. Therefore LCM is equal to product of two numbers divided by their HCF. So you put the value product of two numbers, that is 306 into 657 divided by HCF, that is 9. Then you get the answer. Next question 5. It is very important. Check whether 6 to the power n can end with the digit 0 for any natural number n. So we know if the last digit is 0, that means it is divisible by 5. By divisibility test, you know if last digit is 0, then it is divisible by 5. That is 5 will be a factor. But here 6 to the power n, then the prime factor of 6, 2 into 3, 6. So prime factor of 6 is 2 and 3 only. But we know if last digit is 0, 5 will be a factor. Here, but here 2 into 3 is a factor. No, 5 is not a factor. Therefore, by fundamental law of arithmetic, we know the prime factorization of a number is unique. If 2 and 3 is the prime factors of 6, then it is unique. 5 not be the prime factor of 6. Therefore, it is not possible. Therefore, 6 to the power n cannot end with the digit 0 for any natural number n. So, for your practice work, you check whether 8 to the power n can end with 0 for any natural number n. Okay.